Yeah, yeah.
It is not this one. It is now with
No,
CLT.
this is the, yeah, this one. Should be this. And you have looked over this? You want to go back and forth, or so,
Where is it?
so, or here or over here?
Yes, but I will join when we do the slide about the embedded carbon.
Yep. Okay. You want but make the last one? Okay.
The last one, and when we will have a slide about this pyramid,
Yeah.
I will just put some my comments.
Okay. Perfect. All right. Yeah. Okay. You know, I would say we just start right away. So, okay. Fresh face, next round. This is obviously is a topic close to my heart. My company is called WoodenDataCenter, and you may have noticed the the infamous wooden prototype I brought with me, which we had really positive feedback on that. So the whole idea behind this is to if people are serious about net zero, then we need to dematerialize and change certain materials. And that's the whole aspect of what we're trying to do. And we are thankful for the OCP to announce that we have an OCP sustainability group now, which is also part of all the other existing projects. So the data center facilities actually does have a sustainable project where we now start to look into sustainable construction, certifications, and dematerialization of data centers. And yeah, we have a short time frame here. We cannot go into too much detail, but we want to use the showcase of a wooden rack and the modular data centers that we already have been designing and being compared and compared. So we jump over to what's the issue. You might have heard the keynotes yesterday, and they were quite clear of what the problem is. They solved their scope 2. They all told us about how much renewable energy they deploy, how much renewable energy they use hour by hour. And with that, their problem has become 99% in their supply chain. And so now they basically start over with an even bigger problem because nobody really has tried to tackle those emissions. And that's the real issue. And that's, I believe, why the OCP, especially with those 3 companies, as well as the efforts of Amazon and everybody else in that space, is really interesting to cooperate on this and to work together on this. We saw in the keynote an initiative on sustainable concrete, which is massive. If you can solve concrete, you have solved a huge part of that. And we are now looking into a little bit of a different point. So the question is, again, our example, liquid cooled, how we should build data centers. Is it, can we use, carbon negative steel? Can we use carbon negative carbon? And yes, obviously we should, but those materials are not existing here, and they, especially in the case of carbon zero steel, they compete about the hydrogen that has to replace gas and other resources in other spaces. So we firmly believe that for a lot of technical products, the potential answer could be mass timber construction. The reason for that is, you want to? Okay. So we this is the material pyramid in .dk. You can find that, which is set up by a Danish architecture office, which I try to highlight here so that you see some numbers of how much embedded carbon is associated to a certain material. The reason why my company is called WoodenDataCenter and not Steel Copper Data Center is that on the top of the materials list is aluminum, copper, galvanized steel. That just has a lot of embedded carbon built into the process. And in the in the case of, on the bottom, you see straw, oak, glulam, and CLT, which are materials that are actually carbon negative per kilogram, because the way they see, the way this thing is set up, the way the global warming potential works, they look over the life cycle of a material and see if you are able to, bind more carbon than you emit. And so that's is the unique property of wood in a net zero environment.
I just want to give some comments about the OCP rack. If we take steel OCP rack, the weight of the empty rack is 200 kilograms. So to understand the embedded carbon, we should multiply the 1 kilogram of the steel embedded carbon multiplied by 200. And if we compare that with the cross-laminated based OCP rack, the first thing, we have much less kilograms. And the second thing, that we have negative impact. So in the next slides calculations, you will see that dramatically change.
Okay. So what we're really trying is, the positive effect of bringing the wooden rack here was for people to have an idea on how potentially a net zero future could look like, and also to show a concrete product in the scope 3 dilemma, because this is really at the beginning. It's potentially the biggest business transformation and potentially also the biggest business opportunity. So this is something we all need really to look into. We now are looking at REC and give a hint for the MDC, but we really over the summer until the global summit want to work with the newfound groups to really take a deep dive into modular data center construction. If you change the outer skin of a data center to wood, how much in percentage do we saving? Are we already net zero? Potentially not, because we have so much other components that we can't change that quickly. So that is really what we're trying to do, setting the start point for the sustainable journey of modular data center solution. How potentially in the future does net zero steel play into that equation? That will be the easiest. If we have net zero steel, we can continue as we're doing now, right? We don't have to change any of our materials or our production, but potentially that journey won't be that easy. The work on net zero concrete is super important and will be, is driven by Microsoft, Google, and Meta and together in their paper. So as soon as it's available, it's a huge benefit to the efforts. So what we tried to compare are the models that we had available. The OpenRec V3 is a model that's available, and by my efforts, we designed an OpenRec V3 in CLT. We compare the weight, the volume, and the embedded carbon. So I hope you can see that. So the volume, obviously, steel can be built much thinner. You've seen the panels maybe of the wooden rack. They are thicker. They have more volume, but because of this lower density, we overall have a lighter rack. Believe me, yesterday the rack was here, and I had to carry it over to the new booth outside there, and it was a two-man job. So it can be done. The direct embedded carbons for the 200 kilograms of steel are 300 kilograms of embedded carbon. And if you add up all the steel parts and all the wooden parts, we do actually have a negative, so a climate positive, a net zero, however you want to call it, REC wooden V3, which is something that I was not really sure before we did the calculation if we are on par or if we're still negative. If we jump into the detail of that, we'll try to quantify the amount of steel in both racks, the copper for the bus bar we accounted for, and you can see by adding the material pyramid in front, we actually adding all those things together, because of the negative impact of the wood, building a sum overall, we actually achieve a negative, a carbon negative product. Okay. Any question to that on how we did that? Because the methodology on how to calculate this is not really standardized. So, Simet? Yeah. Uh, That's a very good question. Okay, like maybe it makes sense. Like a very short example of how the global warming potential looks at those things. So the wood is cut, and for the time it's in over its life cycle, it's embedded this carbon. And what makes wood negative is that after the usage of the rack, that wood can still be used for something else. And so after the end of the life cycle, recycling the wood, it becomes negative, because in that case you don't have to cut another tree. If you have your own hand-built rack and you decide to fire it up because you're cold, it's a hard winter, then all of a sudden the wood obviously is back in the atmosphere. So it's not negative, it's a zero-sum game. And so that is a very good question, but generally speaking, in terms of the way they designed a scenario, and global warming is all about the scenarios which are regularly updated, is that you cut down a tree, you process it, and at the end of the life cycle, it can be reused. That's what makes it negative.
So if that's the case, the starting point is when you cut it, but when you cut it, that's a 20-year-old wood. In the earlier 20 years, it actually took a lot of carbon also. We should add that to it. So it is better than -650. It could be -800.
That is a super interesting discussion. We just had literally going into this room, like, we need to standardize this, and I think that should be part of the construction and sustainability group within OCP, because it's wild, it's all over the place, and we need to find agreement. Because I think what you described is considered, but it's not 100%. Yeah.
So outside there is a Rital showcase, right? And it says it's capable to hold 1.4 tons for shipping the fully equipped rack. So what do you think, how much weight can you support with the wooden one?
So the wooden one is so fresh, like the last crew drove off here to Prague to set it up. We've not load tested it. We have load tested the 19-inch wooden racks, and we're confident that we are in that range. We can go up to one, especially with the stability, rigidity of the middle lane that the 19-inch rack doesn't have, and the 19-inch rack we were able to test up to 1 ton in a wooden scenario. So assuming that stabilization, we should be able to at least do 1,200 kilograms, but we will have to deliver that number. And we want to comply according to the spec of the OCP.
Okay, thanks.
So the other question would be, because it's made out of wood, so in terms of humidity or like regions where you have maybe earthquakes, had that been considered?
So that's a nice, good new question. The first question with wood is, does it burn? The production unit of this has a coating, which is not in the calculation, but it's not. The paint has a significant effect, but it will not, reduce the net effect of it. Wood has, in general, better damping qualities for earthquakes and those kind of things. So although we have not tested earthquakes, because where I live, we don't have earthquakes at all, we're confident that it will withstand, an earthquake. But I don't know up to which limit. It just generally dams better.
You mentioned laminated wood
Yeah.
is obviously what you're using. Is there any benefits or differences in the type of wood that goes into the lamination?
Yes.
Oak or pine? I guess pine grows a lot more quickly, right?
So there is one potential option would be in unlaminated oak. Oak binds the most CO2 and has insane strength capabilities in terms of wooden. The whole process of the glue laminated and cross-laminated process is to use inferior wood that doesn't maybe has the best strength, but make it repeatable and create a uniform product basically that behaves again and again the same. So I think it's very often is used pine and a lot of things, but I'll just rely on
I guess pine grows much more quickly than oak.
Yeah.
So
yeah. So usually they try to have really fast growing.
right.
Substances. Okay, that was the calculation. There's one positive. Wait a second. There's one slide missing. Wait a second. I'll open that up. Where is it? Yeah. No. Yes. Here. And that was to WoodenDataCenter, right? In the meantime, any other question until we open our last slide? This one? How is the file called? Can I open that? Okay, that's why I put it into downloads. So. So we have one more slide where David did the calculations and where we want to show in which direction we're heading in terms of an overall analysis, because the rack comparison is really unfair because there goes so much more into the rack and so much more into the data center, but that was just the initial example.
So in that slide, we compare 1,000 servers in air-cooled and steel constructed modular data center with the same 1,000 OCP servers, but in one CLT built data center with CLT racks and liquid cooled. So we compare 1,000 servers and 1,000 servers. But in first case, we have 4 modular data centers, and second is 1. So if we look for the envelope, we have reduced 100.1% the embedded carbon, the same with racks. But we should understand that there is also less container and less racks 4 times. But when we talk about cooling equipment, there is heavily reduction, because in liquid cooling we don't have refrigerants, we don't have mechanical cooling, and for that reason this heavily reduction we see there. And also we need less energy equipment, because installation power is less, as it has liquid cooling. So overall, in integrated approach, we can save 80% in embodied carbon. And I don't touch the IT equipment. So if on top of that we will add the reduction in refurbish IT or CPU servers, the impact will be even much higher.
Yeah, I think we run out of time. We have to give it over to Steve. Thanks so much for taking us through us. We invite everyone to join the Modular data center space, and if you're interested in sustainability, those groups are just getting started. It's a very good time to engage with them and to just learn a lot about it.